Hi, this talk is just about you either call it a clever or a desperate technique I've adopted in Homa in order to try and catch up with TCP in terms of throughput. So I'm not going to go into details about Homa. You don't really need to know much about Homa for this talk, except to know that it's a new transport protocol I've been developing. And its strong point is that it provides significantly lower than TCP when you're operating under high load in data centers and you care about short message latency. That's the benefit it provides. The downside, actually, consistently through the development of Homa, the hardest thing has been actually to get throughput up and have throughput that's competitive with TCP. And one of the reasons for that is the hardware support that TCP has in terms of TSO and RSS that really creates a very unlevel playing field for any other protocol. And I've struggled to try and get Homa to take advantage of those. And what I finally decided is that the only way to really get those benefits is to actually use TCP frames for Homa packets. That's what I'm going to talk about today. The reason for doing it here is I'd like to get your input on this. Is this, how terrible of an idea do you consider this to be? Or is there another way that you know of that we could somehow achieve the same goal without doing this? So I assume everybody knows the basic idea behind segmentation offload. It's really simple. You, instead of passing lots of little packets through the IP stack, you pass one really, really big packet, and then three things happen in the NIC. First is that big packet gets split up into a whole bunch of smaller segments. And then second, the header from the original packet gets copied across all of those segments. And then third, some of the fields of the header get modified in the segments. And in particular, the sequence number gets incremented in each segment after the first one. So this is absolutely essential if you want to get high performance, because in particular, the outbound networking stack is pretty expensive. It's more expensive than the inbound stack. It takes 1 to 2 microseconds per traversal. And so if you're sending a lot of data, you really, really, really need to cut down the number of traversals of the stack. Unfortunately, though, if you're not TCP, it may be difficult or impossible to take advantage of this. So some NICs just don't support protocols other than TCP for segmentation offload. Some NICs will support it, but you have to customize the NIC to achieve that. You can, through various techniques, tell NICs about other protocols. And then there's some NICs that are kind of in between. In fact, the NICs I've been developing Homa on are the Mellanox ConnectX NICs. And they will, if you tell them to do TSO, they'll be happy to do that for protocols other than TCP, except it won't increment the sequence number. It assumes that there isn't a sequence number if it isn't a TCP header. And so what I've done for Homa for that is that Homa has packet headers that look pretty much like TCP packet headers. But in order to work with the Mellanox form of TSO, the header is effectively split. Only part of the header is in the part that TSO will duplicate, the first part of the header. And this is the part that's going to be the same in all of the segments. And then the second part of the Homa header, which has sequence number, actually for Homa, it's the offset in the message, but equivalent to a sequence number. That's actually kept, those pieces of the header actually kept in the individual data parts of the message. So Homa can set those fields different for each of the segments. And then we still get the benefit of TSO, of segmentation off. We can pass one big message down through the networking stack and the NIC will chop it up. And this has mostly worked. But one problem with this is it won't work with zero copy. Because with zero copy, we really want that whole big data chunk to be one monolithic chunk of data coming from user space. We can't insert little snippets of header in the middle of it without having to copy it again. And in any case, this only works with Mellanox NICs. Does not work with other NICs. Okay, so this has made life difficult for Homa. It's been anybody using, for example, Intel NICs so far hasn't been able to get the performance that you get with TCP because I haven't gone and figured out how to customize the Intel NICs. Then the second big advantage of TCP is, of course, RSS. Hashes those to figure out what core should this packet be delivered to. So RSS will work with Homa, but again, what happens is the NICs will not use header fields from TCP's header, even though HOMA has headers that have ports in exactly the same place that they appear in the TCP header. We'd be perfectly happy for those to get used, but they don't get used. So the NIC will only use the source address and the destination address. And in fact, the destination address is almost always the same for all incoming packets. And so really you're only hashing on the source address in this case. And the problem with that then is that means all packets coming from a single peer are going to be processed on the same NAPI core. And that limits throughput. Node to node throughput measurements with HOMA, the most I was able to get with existing RSS was about 60 gigabits per second and this is on with 100 gigabits per second links and with large packets. It's 9K MTUs. Did you want to interject something?
RSS, why not just throw it into UDP?
Why not throw it into UDP?
Yeah, so all the NICs will do RSS on UDP, like they do TCP.
Let me think about that. So the problem with, I think that would work for the RSS side. I don't think that would work for the TSL.
No, I'm just addressing this. So the RSS, I believe, would be completely solved by UDP. So then we can talk about the other one.
I think you're probably right about that. Yep. So the question is what to do about this. So for example, I could try and take advantage of the NIC customizations to support HOMA. I think this just leads to a game of whack-a-mole. First of all, I don't have access to all of the world's NICs. So for example, my test bed only has Mellanox NICs on it right now. There's going to be constantly new NICs developing and feature changes, and the process of keeping it just seems unmanageable, particularly for one person trying to do it. And in addition, this creates additional installation hassles. Anybody wanting to use HOMA has to also install NIC customizations. And then furthermore, are all NICs suitably customizable? I don't know the answer to that, but I'm guessing probably there are some that aren't. And the bottom line is without getting the support, HOMA is going to perform poorly compared to TCP. We'll just never be able to match the throughput. So this, I've been wondering about this for the last couple of years, and I finally decided this is a game of whack-a-mole that can't be won. So what I've decided is if we want to get the same hardware support as TCP, the only way to do that is to be TCP. Literally, the packets have to have IP proto TCP appearing in the IP header. That's the only way to get it. And so what I'm going to describe to you is how I implemented that for HOMA. And there are three problems that had to be solved. The first is we have to make sure that outgoing packets have the protocol in the right place in the IP header. Second, when packets arrive, we have to steal them back from TCP, funnel them into the HOMA stack rather than the TCP stack. And then third, there has to be some way to tell the difference between the HOMA over TCP packets and the real TCP packets. We need to be able to make that that distinction in a reliable fashion. So let's just go through those one at a time. So first, transmitting TCP, the protocol that's sent in the IP header comes from the SK protocol field of the socket. And so I debated about this, but it looks like the only way I could achieve this effect was actually to change that field in the socket during socket creation. It's initially IP proto HOMA, which is how the user requests the socket. And so HOMA, as soon as it creates a socket, it changes the protocol over. This causes all the outgoing packets to have the TCP protocol, but I worry about potentially unintended consequences of this. And I've done my own crude search of the kernel trying to figure out any other place this field is used. I haven't been able to find any place yet, but if you know of some way this is going to cause collateral damage, I'd love to hear about it. And also, if you have ideas, is there a better way somehow to actually get the outgoing IP protocol to be different from what the socket was initially created under? I'd be curious to hear about that. That's setting the protocol field. Then how do we steal back the packets? Well, the flow when a packet arrives is that it first goes through GRO, and GRO is handled through, there's a dispatch table that each protocol creates with a few entries in it, and there's a table indexed by the protocol. So when a packet comes in, the IP protocol indexes into this table, find the GRO receive method and call that function. So what HOMA does is it makes a copy of TCP's table, and then modifies the entry for GRO receive, leave the other ones as they are, and then overwrites the entry in inet offloads so that it now points to HOMA's copy of this table. Then when TCP packets arrive, they actually go to HOMA's. Actually, HOMA has two GRO receive functions. One is it's a native one, and one is the one where it's basically stealing TCP packets. And so inside that function, then it checks to figure out if this packet is a real TCP packet or actually is a HOMA packet. If it's a real TCP packet, then it just gets redirected back through TCP's dispatch table to the TCP offload mechanism. And if it's a HOMA packet, then it changes the protocol in the packet header back to IP proto HOMA, so that from now on, that packet will be dispatched correctly to HOMA right off the bat. So this introduces a small amount of overhead for TCP where we have to redirect into the HOMA method and then back to TCP again. And then finally, the third thing, how do we identify HOMA packets and distinguish those from TCP packets? So the question is there some combination of values in the packet header that it can come up with that TCP would never, ever use? And after poking around a bit, what I've done so far is two things. First, store a special, sort of unusual value in the urgent pointer field, but also set the urgent flag to 0. So the assumption is that normal TCP frames, if the urgent flag is 0, the urgent pointer is also going to be 0. So you would never have that combination. And then in addition, set two flag bits, RST and the SYN flag, set those both to 1. I believe those would never normally both be set to 1 at any point by TCP, but correct me if I'm wrong on that. And I'm using that combination. However, actually, as I was putting together the slides, it occurred to me maybe there's really a better way to do this. Maybe instead of this, is I should just use a header option. And I could define a header option that is specifically basically shunt this packet over to HOMA, and then there'd be no need to pray that nobody actually uses this particular combination of fields in the TCP header. So the status on this is pretty easy to implement, only took a couple of days. I mean, it appears so far to be working, meaning if there are unintended potholes, I haven't stepped into them yet, but the question is there something out there that's going to make this actually fail? And this solved the throughput problem. So now, 2-node throughput is basically full network speed. So conclusion is that it's great that we have this hardware support for TCP, but it really entrenches the TCP protocol and creates this non-level playing field that makes it very hard to ever displace TCP, even with protocols that might otherwise be better. So until there's a better mechanism available, the solution here is just to use TCP effectively as a datagram protocol. It gets us these nice benefits, and then we can use that underneath underlying other protocols. The implementation appears to be straightforward. So, question is, for discussion, really, my reason for being it. So, how bad of an idea is this? Clearly, it's not. If you tell me this is a horrible kludge, I'm going to have trouble coming up with a good argument against that. Is there any chance something like this would ever be accepted for upstreaming into the kernel? Are there better ways to do hijacking, to use TCP? For example, is there a way to do it without having to modify the SK protocol field in the sockets? Or is there a better way to achieve the whole, is there another way to get the whole goal without doing this? I'm very agnostic. I'm not religious about this particular approach. I'm just trying to get performance that can be competitive with TCP. So if there's another way to do this, I would be delighted to hear about it. So that's the talk. I'd be happy to, I'm prepared to accept your flames. I will not even don my flame-proof suit.
So doesn't multipath TCP versus TCP run into the same problem with SK protocol? Shouldn't there already be a solution for this? Because if you set SK protocol to TCP, won't things like domain fail?
I don't know the answer to that. You have to tell me.
So I'm one of the multipath TCP maintainers, and it's different because multipath TCP subflows are actually TCP sockets inside the kernel. TCP does all its reassembly and stuff, and then it's handed off to higher level socket that does multipath stuff. And there's there is some messing around at lower layers of TCP, but in different ways.
That actually suggests a solution, which is create a subsocket that is a TCP socket and send from the subsocket instead of from the main socket.
I don't think that accomplishes quite what John.
Would that require HOMA packets to go through the full TCP stack? It really would not want that to
Create
happen.
the socket, but don't send it for the TCP stack. But that way you can use that subsocket. The main socket will still have HOMA. The subsocket would be TCP, and you would send
I see.
kind of that.
I'm not familiar with subsockets, so that may be something I need to go and learn about.
Well, I don't think it's a concept that exists as say, but I mean, multipath TCP does that, right? So you're in the kernel, you can create another socket or a socket-like thing. For the hijacking, I'd recommend just using a unique destination port and just basically, again, the subsocket would receive the packets after TCP was done coalescing them. And you could probably get most of the problem go away that way as well.
Sounds like that would still require some of the TCP stack to run on HOMA packets, though, which I'd really rather avoid. Or you're saying still hijack, but just use the destination port as the key for hijacking. I see.
Yeah. I think you would still run the TCP GRO engine, but maybe that would be enough at that point. I don't know. Eric probably has a better idea.
I'm just going to field the hardware one. So first thing, thank you for pointing out these problems that you're having. So we know what kind of challenges people have when they try new protocols on devices. So I'll volunteer to help you on the Intel NICs because most of these, are very easily solvable. Modern NICs, they all have a parser that you can teach how to parse another protocol like HOMA or anything else. So the RSS problem is like straightforward to solve. I think Alex is going to talk about UDP segmentation, which is supported in most NICs as well. So instead of you doing the TCP segmentation, you could use that. Sorry, you're going to, okay. Only thing is your sequence number increment problem won't be solved because that's very specific to TCP. But there is another offload that was suggested in OCP called PISO, which will help you with that. And one of the NICs that is coming out, Intel NICs, soon has PISO in it. So that'll do transport, unaware, segmentation, as long as you tell it where to update the sequence number, things like that. So I think most of the things that you pointed out are quite solvable.
Right. I understand it would be solvable, at least for the Intel NICs. The problem is the hassle of me trying to figure out for every NIC in the world how to solve it. And that feels like if this work I have to do and then users have to install these customizations, that to me feels like it's going to die under its own weight over time. It just won't be sustainable.
Would it be helpful to do like a talk on 101 on how to teach a modern NIC a new protocol? Maybe that might be a good one.
I think that would only work if it was actually like for a number of vendors and for all the common NICs out there. So you need at least Intel and Broadcom and Mellanox and SolarFlare. I don't know what the current companies are.
If you could do a talk, this is a short talk on how to teach all of the world's NICs to do this in one fell swoop, that would be fantastic.
So I'm going back to your proposal about the header and the urge pointer, stuff like that. That's not going to work with the GRO, software GRO. And using headers, specific TCP options is not going to work with RSC because RSC is only looking for TCP timestamp option. If you have any other option in the header, RSC doesn't work. So for Intel, for this NICs based on the Microsoft spec of hardware GRO.
So if I take away RST and SYN and don't use those, but just do the option, would that work okay? So don't do the urgent thing. Don't do any of the original stuff. Just
that would not work for many NICs. It would work only for Mellanox, basically, the NIC you are using right now. Yeah. So I think what you want is simply to use UDP because you don't have any hijack to do. UDP already supports GSO, so you can already can send multiple frames in one system call, and the same for the receive side.
But if I use UDP, then I'm not going to get the sequence number incremented across the various packets.
So you add them like Quick protocol. Quick does that. In each Quick frame, you have the sequence number.
Yeah, but then you don't have zero copy.
Yeah.
So you can get zero copy. You're just going to have to insert a couple of extra frag entries for each one. So like I think iSCSI does this, where it's like it'll take sectors and insert commands ahead of them. You'll end up with like your header in one scatter gather entry or frag.
See. Yeah.
And then your next, so it delps. So you might need to enable more frags to make it work at 64K, just because you're going to end up having to break it up.
I see. Have two frags for each one frag before.
Right. And so as long as you're partitioning at the same length, you basically have your one length of data, new header, and the next length of data. And you can also make it work with UDP segmentation that way. Well, actually, that's the thing is a lot of this stuff isn't too far off from what we've done with the tunnel offloads too, because there's already a thing to do the UDP destination port for GRO. So if you want to actually strip the headers off and just reaggregate all the data into one for one GRO frame, you use the tunnel approach we already have for UDP. And as Tom mentioned, there's already UDP RSS, so that should already be there. And yeah, because we went through this, was it 10 years ago for STT, where it was like they wanted to tunnel using TCP as the header. So yeah, I assumed the answer was already going to be a no, but so I figured, okay, here's the alternative. So yeah, if you can add the extra headers with your sequence number as just extra frags. You just have to break up your fragments on MSS boundaries. And then, yeah, that should cover all of it.
And if I use UDP, is there an easy way for me to extract the incoming UDP packets out within the kernel? Is there a mechanism to somehow get those to come to me rather than being sent to to the user program directly?
I think this is kind of what XFRM does when it's tunneling IPsec over UDP. So you could probably do something very similar.
Just to give a different perspective, have you looked at STT?
If not.
So a few years ago, VMware had basically the same idea. They were trying to do tunnels and they realized that NICs only supported TCP. So what they were trying to do tunneling over TCP. They did take this to IETF. They wrote up a nice draft. It was roundly rejected. Not only rejected to get into a working group item, IETF even rejected it as an individual contribution. The only way you can really reject something as an individual contribution if it's considered harmful. The argument was, and you didn't touch upon this, these are exposed to the network. So now my network ops guys, my firewalls, everything sees this. They're not expecting something else to be in TCP. So it was a pretty simple argument. TCP, world's most popular transport protocol, at least at the time. Hacking it, a little bit dicey, especially for network operations. So that was the one time that I saw somebody try to do this, and I just wanted to get on record that yes, this has been tried before. From a protocol perspective, it was pretty much a non-starter.
I was a little bit worried that creating TCP headers that no normal implementation of TCP would ever use could cause antibodies in the network to get upset about that because they say no TCP packet would ever have this stuff and then just throw it out. That seemed like a risk as well.
So, I apologize on behalf of the community. We've focused way too much on TCP. Vendors have baked it in, routers have baked it in. Trying to break that, it's an ongoing work. And I think we have to fight this. We have to get these guys off of this mindset. There's only one protocol. I thought Quick would do that, but it's had mixed results. So instead of figuring out, oh, we need to support N protocols, they said, oh, we just need to support 2 now instead of 1. A little bit frustrating.
We have an idea to implement the TCP hijacking without modifying the SK protocol because it's not just for HOMA or multipath TCP, it's also for the SMC protocol. Similar things happening again and again. So the idea is already there. So if you look at the socket map implementation, it already replaced all the socket function pointers of the TCP without actually changing any part of the API. However, I don't think we can just use socket map because it's still TCP. But our idea is we could actually provide a socket op with ePPF to rewrite all the socket op without changing the interface of the TCP socket API. Yeah, that's a very brief idea.
And what, do you know how much additional overhead that would introduce if you do that?
The overhead, I think, is not big. However, the implementation could be big because of the ePPF infrastructure. So I'm not sure we have all the key functions, all the infrastructure or data structure in the ePPF available to implement, such kind of, complex protocol. Yeah.
I have a question to John or maybe to Tom. In my understanding, HOMA is dedicated only for data center. It means that there are no firewalls inside or the firewalls are controllable. So this is completely different story from Quick, which is supposed to traverse over the internet. So maybe it's not a big deal for ITF group to apply the standard which is modified TCP only for data center.
Yeah, that's right. HOMA is really intended just for use within a data center.
Okay.
Okay, thank you.